Welcome to LIS 754 Systems Analysis Overview. In this section, we're going to talk about systems projects. What is a system? Well, a system is a set of interrelated components that work together for a common purpose. We can see systems in our everyday lives of how we organize housework, in how we organize yard work. Businesses have systems for everything that's built, a set of processes that work together. In our case, we are thinking about information systems. And an information system is a type of a system that has been created. It is used by one or more persons. It's used to help people accomplish some individual task, a set of tasks, assignments. And information systems are more than just software and hardware. They clearly include data. What is the information that we are processing in this information system? It includes people. People are key to information systems. There are procedures that need to be developed and documented, and policies. How are we going to use this system, and how are we going to use this data and protect the data? In general, systems have 6 major components. Input, the data and information that we start with, that we have. Output, the data and information, how it has changed during the process. It should be different. There should be something different at the end of the process. There is processing, that is the rules and formulas and activities that are going to happen to the input to make it into the output. Control, which is how do we manage that process. Feedback is information from the process. So let's think about this in terms of a system that we can all think about and understand. If we have a payroll processing system, the input would be the hours that someone worked, the hourly rate, their taxable rate, and all of those different kind of components. The output would be what their pay is. It would be a check. It would be information to go to the IRS. It would be information to go to the human resources system. The processing would be the set of rules and the the arithmetic to take the hours. So the first step would be to get the gross pay. Then we would subtract out the then it would be to calculate the taxes and other things, and subtracting that out. Control in a processing system like that, a payroll processing system, would be to make sure that no one could get paid for working more hours than there were in the time period. So if you got a weekly check, you shouldn't be able to work more than 24 times 7 hours, to make sure that people don't get paid twice for the same pay period. Those kinds of things are controls. Feedback would be to issue an error if someone did work 1,000 hours for this pay period. And boundary is where the system ends, what is the domain, what is the problem set, and how do we know what this system involves. When we think about systems, and we think about the process of finding and solving problems, which is what systems do, when we are initiating a project, it is often difficult to find those boundaries. Problem domains, problem areas are not as neat as we would like them to be. And so with payroll, we could see that we could get scope creep, process creep in there. that perhaps people want to do more human resources, keep more information, gather more information. We can see this in other kinds of systems. So if we had a website that we were managing, or a set of websites, we might want to verify links on a regular basis. And so we might want to write a small system that would go through all the HTML, that would find all of the link tags, the href tags, and then try to verify that those links are still viable. It might be difficult to know when that stops. If I get there, do I need to check some of those links? So if I am linking between websites that I manage, I may end up checking links many times. And so trying to define what those boundaries are can be really quite difficult. The other issue with defining problems is that problem domains are very dynamic and change during the course of your project. And so being able to account for that dynamicness, for the changing requirements, is important. And we'll talk more about that as we go through the requirements process. But to be aware of it going in is really important. When we devise solutions, I think it's good for us to understand that they usually require interdisciplinary knowledge and skills. So sometimes that can be in one person, and sometimes we need to work with other people to come up with these solutions. So a systems analyst has a knowledge base of different disciplines. So if you were working in a company, you might need to know things about payroll. You might need to know things about business processes that you might not be particularly interested in, but you learn these things, and these skills can transfer from one problem domain to another. Systems analysis and design is a very cognitive activity. That is, it requires a great deal of thinking and pondering and drawing and figuring things out, but it's also a very social activity. So sometimes these are hard to balance. How do I get the input from all the people that I need to talk to and provide feedback to all those people, as well as have time to sit and think about all of the problems that we're trying to solve. So what makes a good project, and particularly what makes a good project for our class? I would like you to think about having a project that solves a real problem, that can be bounded, that is, can have a reasonable place to stop. Where do we, having good edges, we know what we're trying to solve and how we can get to that solution. It can be defined. We need to be able to define these problems clearly. If it's a large project, being able to divide the functions and the results that we need into phases. That means we work on one section of it, and we consider it done. We get another part of it, and we can work on it in phases. And we want to make sure that we have feasible projects. That is, that the goals can be accomplished, that we will be able to have the resources to complete this project, this set to solve this particular problem, and that it's possible. But we don't want to get, there's a fine balance of dealing with feasibility, of whether something is technically possible or not. We don't want to be bound only by what we can think of right now. So I don't know if you saw the news, but Google has come out with this amazing new contact lens that will check for blood sugar on a continuous basis. Now, this was not really thought of as being possible last week. If someone had said, let's do something like that, I would have not, I could not have envisioned it. But now that Google has done this, you think they were not bound by, in their project thinking, of what was technically possible at this moment. They stretched the boundaries of that. And we don't have the resources of Google. We don't have the ability to change technology at that level, but we often do have the ability to stretch what we know to solve a problem. I worked in a organization that had that was very bound by what currently happened, and it was very frustrating to try to create new solutions, because the conversations when we were doing the analysis was, what can happen, how does this work right now? And that bound the conversation, instead of saying, what is it that we want? We want a project. When we're dealing with projects, we want to think about what is an optimal solution and then find ways to make that happen. So we don't want to be too bound in our feasibility when we're thinking of, is this doable, to what is technically possible, but we do really want to think about that the resources are available and the overall goals are accomplishable.